Let us solve a question on marginal rate of technical substitution. The question is, suppose the equation of an isoquant is, that is, Q is a function of capital N labor which is equal to K raised power 0.5 times L raised power 0.5 which is equal to C, where C is a constant. Then the marginal rate of technical substitution of labor and capital when L is equal to 3 and K is equal to 4 is, the options are being given. We need to find out the correct option. Okay, so we are being given the equation for an isoquant which is being given by this very relation. Let's draw a simple graph to understand it better. So let us say we have the units of labor on the horizontal axis, units of capital on the vertical axis. This is a typical Cobb-Douglas type of production function. Okay, so let's draw the production function like this. Okay, since this is an isoquant, what exactly is the isoquant? Isoquant shows us different combinations of capital and labor which gives us same level of output. Okay, so the very basic definition of the isoquant is with this this curve which I have drawn here, it is actually our isoquant. So this isoquant shows us different combinations of capital and labor which gives us same level of output. Okay, now we have to produce C units of output. Okay, so there can be many combinations of capital and labor which produce the C units of output. By finding out the MRTS, what actually we are trying to find out? We are trying to find out the slope of the isoquant. Okay, so let's write here what is the MRTS, marginal rate of technical substitution of labor for capital, is actually equal to, that is equal to del K upon del L, which is actually the slope of isoquant. Okay, so how did I got this very relation? I will explain. We know that marginal rate of technical substitution between labor and capital is actually equal to the marginal product of labor upon marginal product of capital. And what is marginal product of labor? It is simply the change in the output due to the change in the labor. Okay, and similarly, what is the MPK? That is the change in output due to change in the capital. Okay, when we solve this, it becomes del Q upon del L, and when I transpose it, it becomes del K upon del Q. Okay, so this del Q and del Q gets cancelled. We are left with del K upon del L. Okay, now coming to the question, so we need to find out the MPL and MPK. That is this very del Q upon del L. And what is del Q upon del L? That is the derivative of this very function. If I remove this C, so this becomes production function, and it is like this: K raised power 1 upon 2 times L raised power 1 upon 2. This is our production function. Del Q upon del L means the derivative of this function with respect to L. So if I take the derivative, it becomes 1 upon 2 K raised power 1 upon 2 L raised power minus 1 upon 2. The exponent of L becomes coefficient, and exponent of L is subtracted by 1 by power function rule. Similarly, del Q upon del K means that is the derivative of this function with respect to K. So again, the exponent of K becomes coefficient and exponent is subtracted by 1. Okay, this is del Q upon del K. And what is MRTS? MRTS is simply MPL upon MPK. So this is our MPL, this, and this is our MPK. Okay, the ratio of these two gives us the MRTS. So that means MRTS will be equal to, so if we write this, 1 upon 2 k to the power 1 upon 2 L raised power minus 1 upon 2 divided by 1 upon 2 k to the power minus 1 upon 2 L raised power 1 upon 2. Okay, 1 upon 2 gets cancelled. If I transpose k raised power minus 1 upon 2 to numerator, it will get multiplied with this k, and the exponents of k's will be added up and it will become only k. So we will get it equal to k upon L. You can also do this calculation. Now we need to find out MRTS for labor and capital when L is equal to 3 and k is equal to 4. Let's plug the value of k and L here. So k is 4, L is 3, which that means here, if I draw it here, so the change in that is equal to del k upon del L. Okay, so it shows us the change in capital is 4 units and the change in labor is 3 units. Okay, so what is slope? The change in capital upon the change in labor, which comes out to be 4 upon 3, which will be equal to 1.3. It simply tells us that when we get MRTS equal to 1.3, if we want to interpret it, it simply tells us that we need to sacrifice 1.3 units of here labor for capital. Okay, so we need to sacrifice 1.3 units of capital for one additional unit of labor to maintain the same level of output. Okay, I hope I make myself clear in this video. Thank you.